We have theoretical probability. And we have over here experimental probability. Anybody care to speculate what the difference between the two is? Because people often say, well, theoretically speaking, theoretical probability is what should happen mathematically. And experimental probability is, anybody? Elijah? What's that? Well, experimental probability is what actually happens when you do the experiment. Okay. This is what it says on paper should happen. This is what really happens. You're going to make me, let's do this. Let's talk about this. Theoretically speaking, if I have a deck of cards, which I do, and I said, what is the probability? And when you can't list experimental probability unless you do an experiment. Theoretically, you can sit down with your pencil and say, let's say an ace. What's the theoretical probability that when you draw a card, you draw an ace? Keith?
1 out of 13.
Right, because there's 4 aces, there's 52 cards, but you reduce that to 1 out of 13. That is theoretical probability. Now, I'm going to actually do this. We'll do 13 people. We'll see how many of you actually draw an ace, if I can get an ace. Somebody draw a card quick. You can see if she gets an ace. Ace? 8. No. Theoretically, we should get ace. Oh, it's a joker. Actually, there might be 53 cards. We'll still keep it. Pretend there's only 52. Maybe I'm missing something else. So 3. 6. 9. Five. Someone got these names. 3 in spades. 'Did you give it to me or did I give it to you? Wait, how many we have so far? Who drew? 8 people drew? So theoretically, 1 person in the next 5 should. 4. Somebody give me an ace. Come on. 9. We've got a lot of names.
Go on the corner.
8. Drew, I have a good feeling about this.
Drew. We'll go Drew.
2.
Go right.
3. 7. Wait, you got past 13 yet?
Yeah. Go, Josh.
There's no aces in there. 8 says.
Let's check.
Okay, now we do.
People watching lost them all. I see one. I saw one.
It's the queen.
So
Make sure there's
10 is close.
2.
Oh,
there's
no
races. Just cheat.
2, no.
What are you doing?
Cleaning your last word. Cleaning your last You only get one shot. Do not miss your chance.
Do you have a safe
Are you
there?
ready to pull?
I'll pull again.
We're not gonna stop till we get one.
Hey, you
Don't pull the body. Go, Mitch, go. Wait, it's a guy.
Either one of them. Come on, Em, this is all you.
Not that one. Over. That one. Close your eyes. There we go.
Ridiculous.
Let's go, man. Look at that too. 132. We got it, guys. 132.
Okay, so experimentally, when we did the experiment, it was 1 in 32. Now, here's the deal. Generally speaking, this is true. If we did this long enough, if I did this a million, trillion times, eventually these two, like right now, these aren't even really close. This is like 3 times worse probability or odds. Okay, but maybe the next time I go and, Manny Mormino, who isn't here.
Mormino?
Have you ever known Manny Mormino? Manny Marco. If Manny draws one right now, then bam, it's almost back to what it is it's almost back to what the theoretical probability is, because now it would be 2 out of 33 or 2 out of 34, which is 1 out of 17, and it gets close. The more you do an experiment, usually, it's almost true. The more you do an experiment, the more experimental probability it does come close to theoretical probability. And that's why, that's how casinos and lotteries work. I mean, how do you think these people figure out, how they can give people millions and millions of dollars for winning a lottery ticket? Well, they know based on, those, whatever there is, I've never played it or rarely play something like that. There's 6 numbers, 1 through 40 or whatever it is. They know the exact probability of people winning the thing, and they base their calculations and their money on that. And eventually they know exactly how much money they'll make in the end of all that stuff. So that is the difference between theoretical and another example would